because yesterday we started Trig Identities. All I want to look at, like, these are the two sets that are going to be important. Um, tan, well, I guess technically there's the other reciprocal ones, which it's not really an identity. Why is this taking forever? Uh, Whoops, that's not true. And cosecant. And I got a question in an email about like the x's and like when we do sine is y over x and cos is x or tan is y over x, sine is y over r and all of that. The x's and y's are the coordinates on the unit circle. That's why I use theta. This kind of setup uses x's in here as the variable, but you can kind of change all of these. Most of the identity stuff really worried. We're not really worried about the unit circle part, but any of these x's in here, I would normally just write as theta. So all I want to do today is just go through um, really uh, these multiple choice questions, but not in the sense of multiple choice, but like it's all about simplifying. So I'm just going to go through all of these and those two. One of the things it states up here, assume the appropriate restrictions. So 1 minus sine squared can't equal 0, da 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 da. So does that sound like an okay? I don't want to keep everybody for too long every day. If you missed yesterday, you'll may kind of see a little bit more, and then the video I'll put up when we're done. So hopefully we won't be much more than like half an hour, if that. So if you have these kind of handy, one of the other things, like with this one, we can rearrange. If I take, oh, let's change colors. Again, still not smart enough to minus sine squared theta minus sine squared theta. Those cancel. And you can do that sort of thing with all of them. It's supposed to be an equal sign. I'm pretty sure that's where we want to go first with number 7. 1 minus sine squared theta, based on the identity over there that we just looked at. So this is equal to, we haven't done anything. I'm going to change those to thetas so we don't get mixed up. Cos of theta, 1 minus sine squared. Because of the Pythagorean identity, if I can go, this is cos squared theta. Well, the kind of parallel, if I have x over x squared, that cancels with one of those. So this is left with 1 over cos of theta. 1 over cos is the same as secant theta, which should be one of those answers over there. And that's what these sort of things are looking for. Does that, it's kind of quick, but does that make sense? So that's all I kind of want to do today. I'm going to do different colors for different sides. So there's a squared up there. There's a +1. When I see a +1 and any function, I know I want to go over to here and I see 1 plus tan squared is equal to secant squared. well, tan squared. So I can put secant up into here over changing those. The kind of inverse of that one, x squared over x is just x. So secant squared over secant, that cancels with that, and we just have, could you, if somebody says put it in terms of sine or cosine, you could say it's 1 over cos theta, but if you're simplifying it, to me, that step is okay. Yeah. So far, so good? All of you.
Yes.
You're all allowed to talk. If we have any questions.
How is this different than what we were doing yesterday?
Well,
Is it
it's the same thing. I just wanted, like, if we were doing this in class, I would do some and here's some practice. Then we do some more and here's some practice. So today I just want to do a couple more examples just for different scenarios. And then this will be all similar to the questions that are in that little assignment. So, and then tomorrow we'll talk about that second section, which is more about technically proving identities, which is the same idea, but does that make some sense? Just in case.
yes?
Just in case.
Sorry if that sounded rude.
No, no, it's a whole different ball game. It's just like typing, and sometimes things sound different, and people interpret them to be different things. So this is, I think, number 9. We know if I want to simplify this one, and I have no like, I purposely left out the multiple choice parts. I know cosecant theta is 1 over sine theta. Cotan theta is, so I'm going to write this one in terms of sine and cosine. So my numerator is now 1 over sine theta. My denominator is cos theta over sine theta. Well, fraction over a fraction, we don't want to deal with that, so we take the first one, 1 over sine theta. We're going to multiply by the reciprocal. The reciprocal of that is, come on, brain, sine theta over cos theta. Those now cancel. We have 1 over cos theta, which we could also write as secant theta. And this is kind of a classic sort of simplify one in terms of sines and coses, or express it as one. When you have two that are kind of reciprocal, I mean, technically those are both reciprocal, but you could do sine over tan or sine over secant and do different things like that. Just because I may need a little bit more space for this one. So I kind of like a question like this. Write something in terms of sine A, or to me that means sines and whatnot. So I have two parts because this is a fraction. So this is tan of A over secant of A. So not knowing where everything goes, I see a cos squared. I know I could say cos squared A equals 1 minus sine squared A and put that in there. That might help. But I'm going to put tan and secant in terms of sine and cosine, and then we'll see what we can do. So we have our really big fraction. Tan is sine of A over cos A times cos squared A. Secant is 1 over, that just doesn't look right, cos of A. So all our first step is just put everything in terms of sine and cosine. I don't like the fraction over the fraction, so I can leave kind of the whole numerator as 1, sine of A over cos of A, times,
Mr. McKay,
yeah,
I forgot to mention that somebody wanted it recorded. Oh, it is recording. Okay, sorry.
yeah,
Record. Sorry.
oh yeah, I'm gonna, for any of the things that we do from here on out, I'm just gonna record it and put it up just in case, because I know like somebody could be working, somebody, because I know a pile of you are still working. I think I,
I've seen the red dot like on the thing.
oh,
Because you work both your teams too. I didn't see
well, I,
the program.
um, Teams, I did that one day, and then this is the smart recorder, which in terms of file size, this produces a file size that is significantly smaller, so it's just easier to upload and all of that. So I've left this numerator, and then I want to do this, so I'm going to change that to multiply by the reciprocal. Well, this is going to be interesting. So those are going to go away. So now we have, well, I'm going to have to use that sine A, unless I've totally messed something up. Because that's just, did I, tan over secant, tan is sine over cos, cos squared, in terms of that. What are our choices? Is that one of our choices? And there it is. So, whoa, I don't want to do that. If I expand that, sine times 1, sine of A, sine times sine squared, and sine cubed of A. And doing calculus, you may want to use this. Sometimes factoring something out makes things a little bit easier, but it's still, it's not necessarily a simpler equation. It's sometimes just changing how it's formatted. Now we don't have a fraction. In calculus, doing a derivative or something of this is easier than doing a fraction or something like that. So it's trig identities, like Mrs. Legier and myself and Mr. Pellier get all excited for them because they're fun and all of that, but it's about manipulation and changing things to a form that you find a little bit more preferable. Well, subtract, this makes things a little bit more difficult, but secant, well, this one doesn't really matter. Secant of theta is 1 over cos theta. So 1 over cos theta minus cos theta over 1. When we add or subtract fractions, we need to have a common denominator. The common denominator between anything and 1 is whatever that is. So I'm going to multiply this side by cos theta over cos theta. This, the left side doesn't change. Minus cos times cos is cos squared theta over my equal signs. So we have 1 minus cos theta, or cos squared theta, over. So that simplifies it a little bit. I don't know if that's how far they want to go. I think that's where we're going to end up. So cos squared theta plus sine squared theta equals 1. If I move the cos over, so this is, so that's looks fairly simple, but that, if you looked at the answers, I don't think is one of them. And this is a trick. Sine squared theta is sine of theta times sine of theta all over cos theta. And trig identities are something that practice noticing things. You're not going to get these all at the very beginning, but when I see that, sine over cos is now tan of theta times sine of theta, and we've changed a subtraction to a product, which is usually a little bit easier to deal with. Any questions? Be happy. I've only got 2 more to do, and then I think we're good to go. Wow, 22 might be a record. Jensen, shoot. Question, the one that we did up here.
Yeah. I just don't know why the final paragraph sign was Q.
So when my last step, I expanded it, so I multiplied sine times sine squared. So this, in terms of x's and all of that, like if this was, whoops, x is what that's sort of equivalent to. So that's just x, and x times x squared is x cubed. Okay, and it's just the way that, like, all of this is the same idea. The math is all the same as if we were using x's and y's. We just kind of have to use those relationships, which now looking at that, because I've written all over it, looks awful and horrific. But all right, so 13 and 14. Oh, look at this fun stuff. Oh, I love it. 1 over all of this mess. Oh dear. Well, and they state normally when you do identities, it's not necessarily about what the restrictions or non-permissible values are. Tan can't be 0. I don't know if any of you just heard that. What did your mother say? She said no? Can you give me 10 minutes? I don't, she was in there with you. Kids are great. I don't like this 1 over, but this is all of these. I can kind of break this into 3 different things because it's a product. One over tan I'm going to leave the cos alone. But 1 over tan, is this not just cotan? Oh, that's... And 1 over cotan is just tan of theta. Okay, that's all well and good. Cotan is cos of theta over sine of theta, 1 over cos theta, and tan is well, now we have really one giant fraction that we can start just canceling things. I've got a cos upstairs, a cos downstairs, they go away. A sine upstairs, a sine downstairs, they go away. So we're left with 1 over cos theta, which really is just secant theta. It looks intimidating, but any fraction where it's multiplication, the trick is to just break everything down. And that's going to be our kind of strategy. Hopefully, I haven't, they say 1 over cos x, same thing. All right, last one, and we'll give you guys a break. Hopefully, tan cos 3, okay, that's weird, and secant. So I just looked at the answers and saw a whole bunch of stuff. Again, this is an experience thing. I know what the answer is already. If we don't know, we're going to tan sine of theta over cos theta over 1, 3 over 1. Secant is 1 over cos of theta times cotan, which is so. Because I've got things, is there something in the numerator that can cancel without worrying about multiplying by all the reciprocals and all of that? It's multiply and divide. We can do things kind of almost in whatever order we want, but I know that cos and cos cancel out. So I can get rid of those. So my new numerator is sine over 1, which is just sine of theta. The denominator, there's nothing that cancels with the 3, but again, cos and cos cancel. So we're left with 1 sine theta. I don't like that color, sorry. My neuroses. 1 over sine theta. Now I just have to go back and look at that answer. Okay, we're good. That 3 on the bottom is fine. Sine theta, or well, I can pull that out and say 1/3. The reciprocal of 1 over sine of theta is just sine of theta. So those multiply out. Sine times sine is sine squared theta, which is one of the answers that's there. But I think kind of the key strategy for most things, unless you see a 1 minus sine squared or 1 plus tan squared or 1 plus cotan squared, a lot of the initial simplification is all about putting things in terms of sine and cosine, because that's what we did for these two. It was just really, I played with that a little bit. You don't necessarily have to. sine and cosine. That was the common denominator one. That's kind of tricky, but it's still slick. Sine and cosine, sine and cosine. That one used a Pythagorean identity. The first two used kind of the Pythagorean ones, but the simplest way to do everything is putting things in terms of sine and cos. So that's all I wanted to do today because that should help with right each expression. Wow, that one's kind of boring. And the question about variables, if you want to change any x, you can change it to a. I usually prefer theta, but any of the variables at the end of those, you can change to x, a. Like that one has a t.
I have a question.
Go ahead.
Are these all going to be highlighted if we go onto the assignments or files? Or
If in here, what am I looking for? The assignments, I think I just wrote the questions down, but if you go into the files, and I think it's called, oh, that's chemistry, so that's not going to help us. The when I say, well, apparently I misspelled trig, but in this completed notes one, I'm pretty sure those questions are highlighted.
okay.
I don't know what page they're on, and I don't know why it's not scrolling.
Don't worry about it.
But it's in there. It should be highlighted in there. It's gonna be about like the 6th and 7th page, or 5th and 6th page, I guess. So that's all I kind of wanted to do today, unless anyone else has any other questions. That was kind of my thought to just do a couple more examples. If you look ahead, the second part, after I get past all of this mumbo jumbo, is solving, is like technically proving an identity. And you can do it with putting values in and using the numbers, but I might do one with, well, put pi over 3 in and figure it out. But it's really all about proving them. And we'll go through some examples tomorrow. And that should be, there's much more to this, but to get you touched on a bunch of different topics that we need you to be done, we just don't have time. And if we have more time at the end and we kind of fly through the other stuff, we can go back and look at some of the other different identities. Because like I can probably Google, don't mind all of the Amazon stuff that if you just saw that, Trig identities. My wife is buying random things on Amazon, lots and lots of them. So that's a whole page of all sorts of different, oh, over here. These are all sorts of different identities. There's addition and subtraction identities. There's supplemental, there's quotient, there's Pythagorean, there's the negative ones. We kind of talked a little bit about that. There's double angle, there's half angle. Like, there is a lot to it, but we just, because of this silly situation, don't have time to do a lot of it. I can down the road point you in a direction of things that may be handy, but it's just to touch on it for now. So that's all I wanted to do, and unless anybody else has any questions, I think we're good to call it a day because I don't want to keep everybody here all day. Any other questions? Well,
No, thank you.
I guess we're done. We'll see you guys all tomorrow. I'll post this for anyone who missed it, and have a good afternoon.
Thank you.
Welcome.